Welcome to Maximums and Minimums. Local ones too. We'll find out exactly what I mean by that in a moment. So when I'm talking about the maximum or minimum of a function, as you can probably guess, I'm talking about, for the maximum, the y value of the highest point on the graph, or conversely, the largest value of y achieved by the function. Usually, it's going to be easier to look at the graph to determine where the maximum is. Unless you end up going into calculus, in which case you find other tools. Minimums? Pretty self-explanatory. Just replace highest with lowest and you have the same definition over and over again. What this means is graph your function, look to see where it's short, look to see where it's tall. Yay. When we're talking about maximum minimums, we're asking for the output of the function. So we are looking for the y value. The x value is where the point is located. So if I'm asking for the minimum area of a box, like you will see in some of your homework, it is talking about the actual area of the box, not the amount of length that you are cutting out of the paper, which you will then fold up to form the box. So keep those two distinctions there. Now the other thing that you might not think about too often is relative or local max or min. These occur when the function either bottoms out or peaks in a smaller area. So we're going to take a look at an example. Back over here to Desmos, and let's grab our calculator as well. If we look at this function here, you see that it comes down, bottoms out here, but it's not the lowest point on our graph. Then it comes back out, peaks, but it's by no means our tallest point. Back down, well, here's our actual minimum, and then it goes back up. So, we're on a nice tool. Let's actually take a look at these points. One nice thing is, Desmos automatically looks for these important points. So it tells us 1.28 and negative 7.61 is the location and the value for the absolute minimum for this function. If we're still dealing with function, we can have this point up here, which is negative 0.35 for the location and a maximum of negative 1.47. And oh look, it's a negative number, but it's still a maximum. But keep in mind, this would be a relative or conversely a local maximum. And then we have a relative or local minimum at negative 1.68 with a value of negative 5.03. So those points are all nice and easily found using Desmos. But once again, don't expect to have your laptop sitting in front of you while you're taking your exam. So let's look over at our TR-84. We'll want to turn it on. Don't show this message again. I have no idea what that message was. Go to the y equals. Well, we still have our old function stored in from the last time we used this. So let's go ahead and hit clear. Now we have that space open. So let's go ahead and type in our new function. So x raised to, which you'll want to use this little upward arrow down below the clear sign to get the exponents. Fourth power. Notice how we're still in the exponent, but we want to go on to the next thing, so hit to the right. Plus x raised to the third. Go to the right. Minus, make sure you click the buttons properly, minus 4x. Well, we can either use the exponent or just hit the squared button, because our calculator has that one since it's used so often. Minus 3x minus 2. Go ahead and hit enter. Now, one thing I always suggest you do, double check that you put it in correctly. So x to the fourth, okay, plus x cubed Alright. Minus 4x squared. Alright. Minus 3x. Yep, that looks good. Then minus 2. Alright, so it does look like we did enter it correctly. Always nice. Let's go ahead and hit graph. Okay, so we see our points there. Well, we could zoom in on it, which it looks like it goes down to about -10. Yep, our window. Let's go ahead and switch it to our standard window. Easier to tell what things are. Alright, let's see what we have here. So it's down here completely. Pretty useful. But we want to be able to find those mins and maxes using our calculator. So hit second and calc, which is right above the trace button. And notice how we have minimum and maximum available. Well, let's go ahead and find the absolute minimum first. So you can either go down to the 3 and then hit enter, or you can just hit the 3 button directly, and it'll do the same thing. So the first thing it does is ask for a left bound. So you want to put in a value that's left of your minimum. Well, our cursor is to the left of the minimum. Hit enter. Now our cursor, it wants a right bound. So hit to the right until you get to the other side of the minimum. And hit enter. Now I want you to guess. In general, the guess makes the closer you are for that, the quicker it is to get to the actual answer. It's based on algorithms that you might learn if you're doing a lot of computer science stuff. So use the cursor, get close to where you think it is, hit enter. And it now has our minimum, which the minimum is -7.612199 at 1.2766898. How many decimals do we want? 3. Unless there's a reason to give us other than 3 decimal places, give 3. And make sure to round appropriately. One situation where you will not give 3 is when we're talking about money. And how many are we going to give then? 2, because that's talking about the cents. Now you'll go through the same type of procedure to find the maximum and the minimum, and that'll work for the local as well as the absolute. So we're going to wrap that up there. Feel free to practice this out. Find those other 2 points. They should match pretty close to Desmos, but keep in mind Desmos only give us 2 digits, so your calculator is actually slightly better for you there. See you later.